Hello everyone. Today we're going to be solving radical equations. Now when I say a radical equation, notice that all of my equations have a square root symbol on one side. So it's either on the left or it may be on the right. Now when you have to solve a radical equation, we must first eliminate the radical. And to do that, you need to square both sides of the equation. Now, once you've done that, you're going to solve for the variable. And when we have to solve for the variable, you're either going to end up with a one-step equation, which is nice, or you can have a two-step equation. That's why I wanted you to be able to solve your one steps and your two steps. So let's begin. Now this first example is very simple. You will not see this on your test. I'm telling you, it's too simple. I have the square root of x equals to 5. Now in order to solve for the x, I need to get rid of this radical or square root symbol. So remember, my rule says I'm going to have to square both sides. So there's my square, and then over here I'm going to square again. Now by squaring both sides, what happens is the square cancels the square root. And that leaves you with just x, because that's what we want, equals, and if you square 5, you get 25. Because remember, 5 squared is just 5 times 5. And 5 times 5 is 25. And we're finished. Now on your test, you will see problems like this one here or this one here. So let's solve for our variable. Now once I see the square root, I'm like, okay, I have to get rid of that. And to do that, I have to square both sides. Again, the square cancels the square root sign, leaving you with what's on the inside, which is x minus 4, equals, and when you square 3, you get 9. Now, isn't this a one step? So if I want to isolate my x, I just need to get rid of the 4. And this is connected by subtraction. So I just need to do the opposite. I just need to add 4 to both sides. Notice I'm writing a plus 4 here and a plus 4 on the right. When I do my arithmetic, that goes. I get x all by itself, and 9 plus 4 is 13. So my answer is 13. Now, since you're taking the TASC test, they're not going to give you any situations where your answer will not be valid. But if you want to check, you can. So I have the square root of x minus 4, and it's supposed to give me 3. So I have the square root. Now I worked out x is 13, so 13 minus 4, I'm supposed to get 3. Okay, I'm going to do what's on the inside. 13 minus 4 is 9, equals to 3. The square root of 9, 3 equals to 3. So my answer of x equals to 13 is correct. For you guys, you're going to have it simple, and as long as you do the arithmetic correctly, you should have no problem. Let's look at this problem here. I have 6 equals to the square root of x minus 2. So I want to solve for x, so I need to get rid of the square root. So let that word help you, square root. So I'm going to have to square both sides. Now if I square 6, that's 36. Remember, the square cancels your square root, so this cancels that symbol, and you're left with just x minus 2. So if I want to isolate my x, I need to get rid of the 2, which means I would have to add 2 to both sides. My x is isolated, and 36 plus 2 is 38. And I'm finished. That wasn't so difficult. Okay, let's look at some of these problems. These ones I would call medium difficulty. So again, I'm solving for x, but as always, I need to get rid of the square root. So I'm going to square both sides here and here. Now, 10 squared, which is 10 times 10, that gives me 100. Remember, the square cancels the square root, leaving me with x over 10. So remember, that's x divided by 10. So remember, this was the multiplication principle. So x equals, and to get my answer, I just multiply diagonally. 100 times 10 is 1,000. So x is 1,000. Here I have the square root of 10m minus 1 equals to 3. So I want to solve for my variable m. I need to get rid of the square root. So I'm going to square both sides. Remember, this square cancels the radical sign, and you're just left with what's inside. 10m minus 1 equals 3 squared is 9. Now remember, this now gives us a two-step linear equation. And we can solve a two-step. Remember, for those folks who are having difficulties, I put a box around my variable. And remember what that box tells me to do? Get rid of the 1, not the 10. So I'm going to do the opposite. I'm going to add 1 here and 1 to the right. This is cancel. I'm going to bring down my 10m equals 9 plus 1 is 10. And then finally, remember, the 10 and the m are connected by multiplication. So I would have to divide both sides by 10. And my m is isolated, and 10 divided by 10 is 1. So m equals 1. Suppose I have the square root of 3x plus 4 equals to 5. Again, to get rid of that square root sign, I'm going to square both sides. Remember, the square cancels the square root. So I'm just left with what's inside. However, on the right, 5 squared is 25. Remember, that's 5 times 5. Now, this is again a two-step. So I'm solving for my x. So when I put that red box around my variable, that is my clue. The 4 goes first. It's connected by addition. So I'm going to subtract 4 from both sides. And remember, you're doing whatever you do to the left of the equal sign, you must do to the right of the equal sign. That cancels. I bring down my 3x equals. Now when the signs are different, remember what we do? We subtract and keep the sign of the larger number. So I get 21. And remember, the 3 is connected to the x by multiplication. The opposite of multiplication is division. So I'm going to divide both sides by 3. So x equals 21 divided by 3 is 7. These last two problems are on the difficult spectrum. I don't know if you may see these on your test. I've never taken the TASC test before, but I'm going to put them here because you never know. Now again, we're solving for x. So I have the square root of x plus 3, and then over here I have subtract 1 equals to 7. You always must have the radical all by itself. So your first step is you need to get rid of this minus 1. And in order to do that, I'm going to have to add 1 to both sides. So you must get rid of anything that is attached to your radical. This cancels. I get the radical by itself. So I have radical x plus 3 equals, and 7 plus 1 is 8. Now we can now focus our attention on trying to get x by itself. And in order to do that, we're going to have to square both sides. Now remember, the square cancels the square root, leaving me with x plus 3. And if I square 8, it's 64. And I end up with a nice one-step equation. And we like one step. Because if you're solving for the x, the only number connected to it is a 3 by addition. So if we do the opposite, we're going to have to subtract 3 from both sides. The x is isolated. 64 take away 3 is 61. And I'm finished. There's my answer. X equals to 61. Over here, I have negative 12 equals negative 6. Now remember, this negative 6 is multiplying the square root of b plus 4. And remember what I said. Whenever you're solving these problems, you must have the square root by itself. There should be nothing added to it, like this situation. And there should be nothing in front of it where you have to multiply. Now, if I need to get rid of this negative 6, remember it's connected by multiplication. The opposite of multiplication is division. So I have to divide both sides by negative 6. Now that cancels, and I get the square root of b plus 4. Now on the left hand side, 2 negatives gives me a positive, and 12 divided by 6 is 2. Now remember, I'm still trying to get that b isolated, but I still have that radical square root sign. So I'm going to square both sides. Remember, the square cancels the square root, leaving you with b plus 4. And 2 squared is 4. And I want to isolate the b, so I need to get rid of the 4, which is connected by addition. So I do the opposite. I minus 4 on both sides. That is cancel. I have my isolated b on the right. And when the signs are different, I subtract. 4 minus 4 is 0. And I am finished. B equals to 0. So these last two problems are in the category of difficult. And you may or you may not see these types of problems. I hope these videos have been helpful. Good luck in your TASC examination.